Now I want to talk about formatting output with MATLAB. We're used to now, we've used the display function many times now just to display whatever we put inside these parentheses out to the command window. Well, there are ways to format that, and the two functions that we primarily use are fprintf and sprintf. And they basically form the same, except for fprintf doesn't return a value, or it does return a value, but it's not the string. It prints directly to the command window. sprintf returns a string. And just to keep it simplified, we're going to stay with that. fprintf prints directly to the command window, and sprintf returns a string. Okay, so now I'm going to focus on fprintf to show all the formatting capabilities of that function. And since sprintf works exactly the same, except for it returns a string, then by covering fprintf, I've covered the details of sprintf. And then I'll show a couple of examples which delineate sprintf from fprintf. So let's go in here. Let's write some examples first of all. So if I come in and put fprintf, and let's say let us count 1, 2, 3, and then I say printf that was fun. What's going to happen in the command window is not what most people expect. What's going to happen is it's going to print out let us count 1, 2, 3, and then most people anticipate, since I started a new line here, then a new line will automatically start down here, but that's not the case. So what will actually happen is that was fun will print there, and the cursor starting the next line, instead of it usually being back over here, the next line cursor will actually get stuck over there. And the reason is you did not tell MATLAB to start a new line. The way you tell MATLAB to start a new line is you have to insert a special character, \n, which is a new line character. Okay? And so the way you do that is you put it inside the quotes, and you go \n, and you put it inside the quotes. And if I did another one down here, \n, and put inside the quotes, now my output doesn't look like this anymore. Now it prints out let us count 1, 2, 3, puts an invisible character which causes the a new line to start, and then that was fun prints, and then another new line character happens, and then our command prompt is now over here. Okay, so the \n forces a new line character, which you can't see the actual character, but you see its effects. The other sort of hidden character that's important to know is the tab character. Let me illustrate that here. Is if I did fprintf and I said let us count \t for tab 1, \t for another tab 2, \t give me another tab 3, and then I'll go \n to give me a character return, and then put the quote to close off the string. So \t is a tab character, and so my output, what's printed in the command window, because fprintf prints directly to the command window, what's printed in the command window is let us count, then there's a tab and the number 1, a tab and the number 2, and a tab and a number 3, and then a carriage return, and so I would get the command prompt over there. Okay, so \n and \t are what we call control characters. There are a few others, but these are the main two that we'll use for formatting output. Okay, now the other thing that I want to show you is how MATLAB allows you to put data into an output string. And that involves the special characters, and let me put these over here too, %d, which allows you to insert an integer, %s, which allows you to insert a string, and %f, which allows you to insert a decimal number or a double or a float. And so these are sort of the magical characters that you need when formatting a string. So let's go let's do this. Let's define something first of all to put in the string. So let's say if I say my integer 1 is equal to the number 1, integer 2 is equal to the number 2, and integer 3 is equal to the number 3. So these are my data values. Then I come in here and I do fprintf let us count, and then I put in here, instead of the numbers 1, 2, 3, I put in %d, which is going to hold a space for an integer, comma %d, which will hold a space for another integer, comma %d, which holds a space for another integer, and then I finish my string, maybe with a period, then a \n, so I have a new line. And then at the end of my string I put a comma, and then I give it the values to fill into these placeholders. So I want to fill the first one in with int 1, the next one in with int 2, the next one in with the value in int 3, and I close it off. So what's going to happen is when this executes down here in the command window, the value that's stored in variable int1 goes in that placeholder. The value that's stored in variable int2 goes in that placeholder, and the value stored in variable int3 goes in that placeholder. It's not the numbers 1, 2, 3 that matter, it's the locations. Whatever value you put in the first location is going to go into the first placeholder, the second into the second placeholder, and the third into the third. So what will be printed out here is let us count 1, 2, 3, and then a carriage return. Now, this looks just like I just typed in let us count 1, 2, 3, but it now gives us power, because if these variables change, if I do some kind of function which I'm calculating these values or what have you, I can then put my calculations into my output, and that's some power to be able to display the output of your calculations in a formatted form. Okay, so let's look at this. Let's look at this similar example, but using strings. As I said, the holding character for strings is %s. So if I do string 1 equals 1, string 2 equals TWO, and string 3 equals THREE, then if I do fprintf let us count, and if I do %s, comma, %s, comma, whoops, make this a little bit smaller, %s, comma, %s, comma, %s, and then maybe I put a period, \n for my carriage return, then a comma, then I tell it what values to put in here. I'm going to put str1, str2, str3, and once again str1, because it's the first location, will go in there, second location goes in here, third location goes in there. Okay? And so now the output is let us count 1, 2, comma 3, because it is filling in, and then a carriage return here. It is filling in these string values into these placeholders. Okay? Now, a lot of times we have decimal numbers, and there's always a question of how many decimal places and what have you. And so MATLAB lets you format decimal numbers as well. So let's say if we had a vector, and you can use this, you can use vectors with this as well. Let's say if we had a vector data, and data had the values, let's see, 2.98, 67.1289, and 1099.357. Okay, and so these may be some random data points. I want to erase this here, give me a little bit more room. Okay, so I have these data points, and now let's say the nice thing about when you do a decimal points, a lot of times you want to print stuff out in column form because it just makes it a little bit easier to see it in columns. So let's do this. Let's do a fprintf, and let us count once again, and then we're going to put an immediate carriage return here and start a new line, and then we go fprintf, and then let's say I want to tab over a little bit with my columns, and then I want to put %f, and then a new line character. Okay, so let me put quote marks there, and then what I want to put in here is data sub 1, which is going to be the value 2.98. Then I'll come in here and do fprintf tab %f again, new line, and then I'm going to fill that row of my column with data 2. And then I'm going to do fprintf with a \t for a tab, \n for a new line, end quote, and then I'll do data 3. Now this is primed for a for loop, but I'm going to do it here. I'm just going to write it out. But you could just as easily put this in a for loop and have it printed out without having to duplicate these lines. And actually, that actually would be a would be a good practice for you. You can do it in a for loop, you do it in a while loop. That'd be good practice to execute this. I'll leave that for you to do. So what's going to actually print out here if we go to our command window is we'll get the string let us count, and then on the next line we'll get the number, we'll tab over a bit and we'll get 2.98, then we'll tab in the next line because this puts a character return in here, then we'll tab over and print out it will print 67.1289, and actually MATLAB is going to put 2.980000. It'll print out 67.128900, and then it will print out 1099.35700. Okay, so let's explain this a little bit. Let's explain what's happening. This indentation here is controlled by that \tab in front of each one. This carriage return here, of course, is controlled by this carriage return. And the fact that all of these are on a separate line are controlled by these \n's here, which have inserted the carriage return / new line character. Okay, and then this data is filling on each line here. Okay. Now the formatting here is it throws a whole bunch of zeros. If you notice, it's giving us 6 spots past the decimal point. So this one, the number we gave it only had 2, so it fills it with 4 zeros. This one had 4, so it fills it with 2 zeros. This one had 3, so it fills it with 3 zeros. So it's giving us those numbers across the decimal point and to the right of the decimal point. You notice our decimal points are not lined up. So if we actually wanted to visually add these numbers, that would be a little difficult. So what we want to do here is let's look at some additional ways. There are additional ways, unlike %s and %d, %f comes with some additional formatting which we can do to format the decimal numbers. So let's look at that here. So the way it works is you can do %, you can do an optional 0 here, an optional number here, some number, let's call it in decimal point, an optional number here, let's call that M, and then the F part. So %F, this is sort of the non-tricked out version, that's the basic version, and then down here is the tricked out version. This 0, if you put that there, it will 0 pad, and that will become evident in an example I'm going to do a little bit later. This N tells you the total length of the string, and that includes the decimal point, and I'll talk about that. And then this one over here is the number of decimal places. Okay, so let me show you it in its entirety. If I come in here and I change this %f here to %09 dot, I need a little bit more space here, to %09 dot .4f, and then I'll do my \n and close. Once again, %09.4f. That's indicating \n and close, %09.4f. So this is telling me my format. What does that mean? Well, 0 means it's going to 0 pad. I'll explain that in a second. 9 means the total length of the number, including the decimal point and the numbers after decimal point, is going to be 9 characters long. And then the M tells me how many of those characters are going to be used for the decimal places. So if I did that with this, it would go, let us count once again. And then what it would do is it would start 0 padding. So it would say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 characters long. There are 4 characters after the decimal place, and it 0 padded it. If I didn't have the 0 there, it would just put spaces and you wouldn't see it. You wouldn't actually see the zeros. But I put the 0 in my formatting here, so there are only 3 of them, sorry. I put the 0 up here in the formatting, so therefore it puts zeros, it's 0 padded there. The next one would be 0067 decimal point 1289. The next one would be 1099.3570. So you see now it creates this nice block of text. All the decimal points are lined up. Now, if I did not put this 0 here, then it would look like this, which is how we're usually used to seeing things, but I just want to show you the effect of the 0 padding. So let's now go over to MATLAB. So here we are over here in MATLAB, and I made the font bigger so hopefully you can see this. There's a lot of text, but I want to walk you through this, and I think it explains fprintf fairly well. So I step through, I get to line 7, and fprintf formats a string and writes it to the command window. Keep in mind, it writes it to the command window. So now it's actually going to write that string to the command window. But notice, since there's no, over here, there's no \n, notice my prompt is still way over here at the end because nothing told it to go back over here to the beginning. And if I execute line 8, it tags that onto the end and keeps on going because nobody's ever told it to go back to the beginning. Then it says the above string printed out on one line. Well, it actually yes, it did print out on one line. It did not have a line break character, and so this is and it says at the end. And so this one does have a line break character in it. So when I execute this one, notice that now the cursor is back over here, the command prompt's back over at the end. Also note, and I make the notice here on line 12, is that the line break character forces the window to write on a new line. So it does start back here in a new line. Also note though, here I have a double backslash. And by putting the double backslash, it allows me to print the character backslash over here. So if you just stop the video and look at that for a second, that should be somewhat self-explanatory. So then I come here and and once again the double backslash allows me to print this backslash character here. So now I come in, I put in this on line 13, that's just going to give me a blank line, which is cool, which allows me to separate things with blank lines. So there's also a tab character, which is \T, and you see here that it inserts the tabs here inside or in between these strings exactly where I put them up here in between those words there. So notice how the double slash, once again I do the double backslash here, and it allows me to print the \T. Okay, another line break on, another blank line on line 16. Then I say fprintf allows us to insert data into strings using special holders. And so here I use the tab character. So lines 18 through 20, I use this tab character to indent here, put a space here so that this text down here came out neatly. Notice also I use the double % signs, and that allows me to print just the single % sign here. These are called escape characters because that allows me to escape the normal formatting there. Okay. All right. So now that we've sort of gone over the basics here, let's use the examples and look at the examples I did on the board. Okay. So here's an integer example. I set the values of int1, int2, and int3 to 1, 2, 3 respectively. So I'll do that on lines 24 through 26. Then on line 27, we have let us count, and I have %d, %d, %d. So int1 is going to go in the first place, int2 in the second, and int3 in the third. These %d is looking for integers, and so when I execute line 27, I get let us count 1, 2, 3. The point I'm making here on lines 28 and 29 is that the order is what matters. It's not the fact that these variables labeled int1, int2, and int3. It's the order. So whatever here's first is going to go in the first spot. The second is going in the second, and the third in the third. So now when I execute line 28, I get let us count 2, 3, and 1 because it changes the order based on what the order I put these variables out here. And then I do the same on 29. I show it in a different order as well. So, and then on line 31, I set up a vector called int, and I do that so that I can show you how you can put any value that you put in here. I could have just put a number in here, but any value that you put in here, any integer that you put in there, will fill these slots. And so now I'm going to show it by indexing a vector. And so if you look and follow through this, I will print out 1, 2, 3, 2, 3, 1, and 3, 1, 2 by indexing this vector at different locations in these 3 strings on line 32 through 34. So line 35, I put in once again a blank line and jump down here to a strings example. I set variables str1, str2, and str3 to the strings 1, 2, and 3. Then when I come down here, notice I have placeholders for strings, and I give it the variables here. I have a carriage return, or excuse me, a new line character at the end of each string here. And so when I execute these, they perform as predicted. The string ONE gets put into the first variable here, placeholder here. The string TWO gets put into the second placeholder, and the string THREE gets put into the third one. And so follows with lines 42 and 43. Line 44, once again, I put a carriage return. Please feel free to stop the video and work through this with MATLAB so that you get an understanding. Next up, I show the %f with the decimal examples. Here's my vector that I did on the board. I'm going to, when I do this, I'm going to have to take and use the workspace to show some types. But for right now, let's just do this here. So with decimal examples, this is the vector that I did on the board. I go through, set the data vector, and then I say let us count. It defaults to 5. Actually, I put 5 here. Actually, this is wrong. It actually defaults to 6 decimal places. That's the default. And then here, I show you the effect if I put %.2f. Keep in mind the formatting I showed on the board. It gives us 2 decimal places. On line 50, this is sort of the quote-unquote formula, the % sign. If you want 0 padding or not, you put a 0 there. If you don't want it, you put nothing there. The total length of the decimal number, including the decimal point, and then on the other side of the decimal point, you put the number of decimal places and then the f. So if I count here without doing any specific formatting, just holding the spaces for, this just holds the spaces for the decimal numbers. I get this. Keep in mind, notice there's 6 spaces out to the right, out to the decimal point. That's by default. If I execute again, a little neater version, I align the decimal points by telling it it's a total of 9 spaces, including the decimal point, and then 4 spaces after the decimal. And so this enables me to line up the decimals, which is very, very, very handy. And then this, by putting the 09 here, or the 0 in front of the 9 here, it allows me to 0 pad, just in case you ever would want to do that. Okay. I'm going to stop the video here and then start another one and talk about sprintf. So now I'm going to demonstrate sprintf with a quick example here on the board and then get right into MATLAB. Sprintf returns a value. So if I do something like a equals sprintf hello, and b equals sprintf world, I don't know, let's say c equals the number 42 and d equals sprintf I am %d period new line character and then C. And let me just note, probably want to put spaces after the O in hello and the O in world, excuse me, and the D in world, put a comma there too. So if I do now very simply display A, the vector A concatenated with B concatenated with D, what's going to get printed out in the command window is hello world, I am 42 period with the carriage return, or the new line character at the end. So you can see how what sprintf did is it formatted these 3 strings and then concatenated those strings together and then printed them out. So sprintf, and you do want to put a semicolon at the end of the sprintf lines, sprintf, it actually returned the formatted string and put it in these variable names here. So let's go to MATLAB and look at this. So if I walk through, if I start this code, and begin to walk through. This stuff up here is stuff left over from the fprintf stuff. So let's just concentrate down here. If I say a equals sprintf, printf works the same as fprintf. Okay, so I'm going to load variable a with that string. I load variable b with the string, and notice these don't print. This here is just an artifact of doing the debug, but these aren't printing out. They're just loading these variables a, b, and c with these strings. If we go over here to the workspace, we can see that a, b, and c are characters, and they're typed characters, and it gives actually the length of these strings. One's 35 characters long, one's 90, and one's 81. Now if I come here down to line 71 and actually display the concatenation of these strings, now what gets printed to the command window is the formatted string. Sprintfs works the same as fprintf, and you can see that up here. Then there's a character return, then it says except, comma, and sprintf sprintf returns its formatted string instead of printing it to this command window. That's this. The only reason this is on this line, the window's on this line, is because it's too wide to fit into the screen, so it does a wrap. But then it inserts a new line here, and then it displays the string that's stored in C. Thus, comma, nothing is printed here until these variables are displayed by some means. And the means by which I displayed them here was DISP display. And so that is showing that what happens is these variables actually get loaded with these strings. In fact, if I put my cursor over the variable a here, you can see that MATLAB is telling me it's a 1 by 35 character string, and the value in it is sprintf. Sprintf works the same as fprintf. And then b is the string, except sprintf returns its formatted string instead of it printing it to the command window. And then C is, thus nothing is printed here until these variables are displayed by some means. So those strings are getting stored, and then when we display them, we can display them. So that is really the point of this part of the video. Another example here, let's say I'm going to display, for example, and what I'm going to do is I'm going to format our little table with the number 0 padded, just like we did before. But I'm not going to print it until I actually store all the values. And so now you see D on 74 here. If you go over here and try to bring the command with the workspace in here a little bit tighter, if you see here D is equal to a string of type char, or vector of type char, which is a string. E gets assigned its length 12 there. F gets assigned. Notice nothing else is being printed out on the command window. All that's happening, these variables are getting assigned by sprintf. If these were fprintfs, things will be getting printed out to the command window. So G gets assigned, H gets assigned, just the backslash, and then so all of these are assigned, and then I concatenate them in line 79, and then display the concatenation. And then it actually prints out this whole table at one time. And so, once again, fprintf prints directly to the screen. sprintf returns the value, so you can actually store it in a variable, return it from a function, and then display it by other means. Now I'd like to talk about the input function. And it allows the program, the script, or the function to actually ask a user to enter information sort of on the fly as the program is executed. So let's look at this. This function has a couple of parts. This is a classic example in inputting, asking the user for his or her name and allowing them to input that. So we'll say input, what is your name? And so input function has two versions. This is the first version. And so what it says is What's going to happen here in the command window is this going to do what we call prompt the user for their name. So this string is going to show up in the command window. Whatever the string that you put inside the parentheses of input, that's going to show up in the command window. So the command window is actually going to print out the string, what is your name, with a question mark, just as you wrote it here. If you want a space between the end of the question mark and when the user types their name, you need to put a space. You need to make sure you put a space in there. Okay, so this is what prints out. Now the function or the script that you're running this from stops execution, and it waits for the user to print in a value, and hit the enter key. And so let's say if I just put in, and I denote this as a string by putting the quotes around it, and I do Bob. Okay. Then when I hit enter, what will happen is if I don't display the name, and usually put a semicolon after this, I don't display the name or do anything like that, then nothing will show to the screen, but the variable name will actually get assigned whatever the user entered, which in this case is the string Bob. And then if I did display name, then Bob would actually get displayed to the screen. Okay. Let's say if the user didn't enter a string, but they entered, let's say if they came down here and they entered the number, I don't know, 365. Okay. Then name gets assigned the number of type double, 365, and then when I display that, 365 goes here. Okay. So the other thing the user could do is if the user came in here and there was some predefined variable, let's call it C, and C equaled some name like Buzz, then if asked to input something and they just put a C without the quotation marks, then that's telling it put the value that's in memory location C, enter that, and so what would actually then name would actually hold the value Buzz. However, if C was not defined, then Buzz would be displayed down here. However, if C were not defined, if it were not previously defined, and the user responded with some value that did not have quotation marks around it, like C, or even if they had just typed in B-O-B without quotation marks, right? Because Bob is not previously defined like C was, the computer doesn't know what B-O-B is because it doesn't have quotes around it, so it's not a string. And so in this case, you're going to get an error. And it's going to tell you that Bob has not been previously defined because it hasn't. But if I had, once again, defined Bob, B-O-B up here, to equal the string Bob, then when I do this and type in B-O-B without the quotes, then name is going to get assigned the value that's stored in memory location Bob, which is a string Bob, and so that would actually get displayed and not throw an error. Okay. Now, there's a way around all this string business, which is to assume that the user is going to give you a string. If you want the user to not have to worry with this whole mess about whether they put quotes around it or not, or whether they predefine it or not, you can do this. You can modify input and add to it, after you do your prompt string here, you put a comma, quote, S, quote, and then close it, and then close up your input. That character S there indicates to MATLAB to treat anything the user inputs as a string. So now we don't need that predefinition anymore. If you come in here, it looks the same but with this S on the end, and if the user just put in Bob, and Bob has not been previously defined, because of this S parameter here, then input will automatically convert Bob to a string and not give you an error. And so it's going to say, okay, well, Bob is a string, and then when it displays it as a string. The other thing you might be asking is what happens if the user puts in a number here? Well, what will happen is, because you have this S parameter here, anything that you enter will get turned into a string. So now the 356 actually becomes the string 356, character 3, character 5, character 6. Okay, and we talked about that when we talked about strings. So let's look at this in action in MATLAB and run it. Okay, so now we come in here and we execute. Now I set C equal to Cedric because we're going to use that here in a second. Then I say name equals input, what is your name? And so that's without the S parameter. And so now what's going to happen is it prompts me with what is your name down here in the command window. And the program will sit here and wait for me to enter some name. So if I enter something with quotes, so let's say if I said quote Bob and hit enter, then it executes line 8 and it displays the name Bob. Now if you also look over here, what happened is name, the variable name, got assigned the value Bob, and it's of type char because it's in quotes. Okay. So let's run this again. This time, what I want to do is I want to enter a number. So it's prompting me. I enter the number 365, and I go through this again. Oops, excuse me, I didn't hit the enter key. Hit the enter key, and you notice what happens is name gets assigned now 365, but it's of type double, right? Once again, without the S parameter over here, it just takes it as it is. Let's run this again. Put a break in there. Okay, so now it's going to prompt me for my name, and then I type in, if I just type in capital CDRIC, that hasn't been previously defined. So it doesn't know what that is because I did not put the quotes around it. So now when I hit enter, it gives me an error. Right? And it gives me an error, but then it goes back up and asks me for what my name is again. So this time, let me come in here and put in, instead of Cedric, I put in C. Now keep in mind, I have previously defined C to equal the string CEDRIC. So when I hit enter now, it continues execution. And notice over here, name gets assigned the string Cedric. Okay. And once again, all that whole dealing with the string and all that can be somewhat confusing. So one thing to do is to use this form of the input statement and put the S character here. And so as a parameter. And so when I do that, now I'll run this. It stops and asks me for my name. Now if I put in Cedric, it automatically makes that a string, and so now it's Cedric. Now if you look over here, name is Cedric of type char. If I run it again, if I put in C, now instead of assessing variable C, it treats that C as a string, and so now C is of type char over here. If I run it again, I put in a number, 356. Notice now name is 356, but it is also of type char. So once you put this S parameter here, comma, and the S string, then whatever you put in there is going to get interpreted as a string. Okay? And so this is a way for you to, input is a way for you to interact with the user and actually collect information from the user as the code is running.